Good day, class, and thank you very much for connecting once again at Metric Hub. We are meeting actually to work on end of term 2 examination revision. I just brought to you an exam revision guide, question and answer series, Geography grade 11. And please note that you are connecting at Metric Hub, and Metric Hub provides you with support from grade 8 to grade 12. All various subjects they are covered. So in order for you to just not miss anything, please join membership on Metric Hub. Click join and follow the links or the prompts that will come after you click join on the channel there and become a member until you write your grade 12. I promise you that you will never have any mistakes or anything to regret if you become a member on Metric Hub. You are joining one of the best stop channels or one best stop channel of your choice, which will never leave you alone. So please, let's do it together right now without wasting any time. This is an exam prediction paper. It's just a template. It's a reference for all the various areas of exam questions that would have to be mastered and covered towards this mid-year examination. So without wasting any time, I'm sure that you know when you go to exam, you know that instructions are very key. So always please ensure that you read instructions, read instructions. I always emphasize passing exam is about doing what is expected of you. Instructions are very important. Please check and read instructions very clearly. So let's just go to the questions, and we are starting with climate and weather. Of course, we are under section A, which also involve geomorphology, climate and weather and geomorphology. I'm sure that if you also refer to Metric Hub, we have got quite a good comprehensive list of lectures that are given with reference to the subject areas that you are seeing here. We tried very much to also articulately cover those. So options are provided, but you have the best answer. A force that determines the speed at which air flows from a high pressure region to a low pressure region. That force that actually determines the speed, wind speed. Wind speed is also caused by a certain force. When wind is moving, it moves from high pressure to low pressure region. So this is called the pressure gradient. The pressure gradient, it actually is the force that, of course, created by the variation of a zone of high and low pressure, where therefore now the air has to move based on the pressure gradient. The bigger or the higher the pressure gradient, the more the speed the air can move. So it is a pressure gradient. Coriolis force, I remember, and I am sure that you can remember very well that this is the force of deflection or the deflection of wind as a result of the rotation of the earth. So we talk about Coriolis force on other areas, but in terms of pressure, force and air movement, it is the pressure gradient. That is that uh, when air temperature is dash, air is heavy and sinks, creating high pressure. When air temperature is low, when air temperature is low, air is heavy and sinks, creating high pressure. I just want you to really take note that, note this to say that Metric Hub has quite a good lecture on this topic in terms of aerodynamics and air pressure, and also explaining the pressure gradient and how what we call a low pressure and high pressure region. So now, what is happening here is that when air temperature is low, when air is low, it does not contain more humidity. It is actually heavy. When air temperature is low, the air is heavy and therefore it sinks. That creates high pressure. High pressure. So now what you can see is that we are seeing when air rises, it sinks after it reaches a certain level, which we say that it is the it we are saying it loses heat when A is rising. A rises and then it cools down. It cools down. The cooling down of the air results in it reaching its dew point where it cannot continue rises. It cannot rise beyond that. So now what happens is that when the air temperature is low, therefore what happens is that when the temperature is low, the air cannot rise. It keeps on flowing. It is resting on the earth. As you can see, this is the earth that I'm trying to show you here. When the air is sitting or it's resting, it's actually resting on the earth. If it is not in the atmosphere and it is resting on the earth's surface, we call that there is high pressure. There is high pressure there. The high pressure that we are talking about is the contact that is caused by the air as it rests on the earth. But now, when it rises now, the air is in the atmosphere. It is now in the atmosphere. When air is in the atmosphere, what happens is that the ground has got what has got low pressure because nothing is sitting on it. So now the concept here of high and low pressure, it is determined by the air temperature. When air is hot, when air is warm air, it contains water vapor, and the water vapor has the capacity to contain also or to have the latent heat or vaporization that determines or that contains or that sustains air from rising. So what I want you to know is that when air temperature is low, it is heavy. When air temperature is low, it is heavy and therefore it sinks, creating high pressure. So therefore, it cannot rise so much high because it does not have water vapor within it. When the air is cold, it is low temperature. It cannot have more pressure, more capacity to rise. Instead, it sinks. Therefore, it sits on the earth and then it creates a high pressure. That's one point that I want you to take note of. And then the diagram below shows A. The diagram below shows that A moves. That is very correct. A moves. The diagram below shows that A moves. When the A is moving, it moves from high pressure to low pressure. I'm sure this is one force that we've been talking about just now to say that A can move, but its movement is because of the variation in pressure gradient. So what you can see here is that in this reference, we are given H. This can be also be asked, which you must know this is a high pressure. This is called a high pressure. This is called a high pressure cell. And then, of course, this is called a low pressure. Also, the issue of high and low is caused because of the we are talking about the pressure reading that we can see to say, we are talking about, if you see here, we have got 1012 and then 1016. So now this variation is defining to say that L should be at the center, identifying that it's a low pressure. H also is identifying a high pressure where the pressure or the air is radiating from the center going outward. So in a low pressure, the air converges at the center, as you can see. So now, let's just quickly check the question. The diagram below shows that air moves. And then, okay, it just wants us to show how does the air move. The diagram below shows that air moves. How does the air move? From a low pressure to a high pressure. It cannot be from a low pressure to high pressure. As you can see from the diagram, air is moving from H to L. So it is from high pressure to low pressure. Hence, A cannot be correct. And then from high pressure to low pressure, we have got high pressure to low pressure. The arrows are showing the air movement, which actually shows that it is moving from high pressure to low pressure. Hence, we can actually agree to say that B is showing the air movement from high pressure to low pressure, and then descending air at a low pressure. Descending air at a low pressure, it does not, it would also exclude H here. Hence, C cannot be correct. Rises at a high pressure. We are not seeing also that, because what happens is that air is just moving from high pressure to low pressure. So therefore, the correct answer is what? It is B. B marks the correct answer, which of course is really what is happening. As we go with geography, I'm sure you need to understand that we are going to talk about in Southern Hemisphere and in Northern Hemisphere for this concept. And now I don't want to go deep into these pressure cells to say how do we tell that this is in the Northern Hemisphere and this is in the Southern Hemisphere, defined by the air circulation that we are seeing there. It is a subject for tomorrow anyway, in the next near future. According to the Farrell law, when your back is when your back is to the wind, deflection takes place to the left in the dash. You see, when your back is to the wind, deflection it takes place to the left in the dash. So what is happening here? We are seeing this air movement uh, in terms of the Ferrell's law. So now, when your back is to the wind, deflection, there is deflection of wind that takes place, and then the deflection takes place in the what? In the deflection is to the left, which actually identifies the southern hemisphere. When the when your back is to the wind, the deflection takes place to the left in the southern hemisphere. This is what I was talking about, which is also guided with reference to the air circulations that are in southern hemisphere and northern hemisphere, which I'm saying that Ferrell's law, it identifies that when your back is to the wind, when the wind is coming, and then the wind is coming through, is coming towards your back, there is a deflection or a change of direction of wind that takes place to the left, and that to the left it is in the southern hemisphere. The rate of change the rate of change at the gentle pressure gradient force is only dash hectopascals over 100 kilometers. Uh, rate of change. The rate of change, it actually, we are saying the rate of change at the pressure gradient, which is shown, we are saying it is only dash hectopascals over over 100 kilometers. Over 100 kilometers, we are saying that the the rate of change is only 4 hectopascals. 4 hectopascals over 100 kilometers. 4 hectopascals over 100 kilometers. And then we want to look at when the lines are far apart, the dash, when the lines are far apart, the air pressure gradient is gentle and the wind speed is low, which of course can actually identify that the distance of lines, whether they are close or far, when they are far apart, it means that the air pressure gradient is gentle. Air pressure gradient is gentle and wind speed is low. So obviously what happens is that on a gentle pressure gradient, the speed of wind is low because it cannot be moving so slow, so fast, because of the what? Because of the resistance force of the air to move across that gentle pressure gradient, defining that the wind speed can also be low. Pressure is indicated on a synoptic chart by lines called dash. When we look on a synoptic chart, pressure is actually measured and shown by isobars. Isobars, they show lines. There are lines that are found on the map that are used to measure pressure. We talk about contour lines. We talk about altitude. I'm sure this is one which you people sometimes not understand. Isolates, we talk about rainfall. And then what we are saying is that pressure is actually given by what? By isobars. It is showed by isobars. And then we are given the cartoon which shows drought in Cape Town. Complete statements in column A with options in column B. Write only Y or Z next to the question numbers in the answer book. Subro. And then we are saying after the water went, it was the city's economy. After the water went, it was the city's economy, reputation, tourism, and many other. Welcome to Cape Town. We are in Cape Town. Welcome to Cape Town. And then we are having the Glock. So now we are given that the cartoon suggests the area to have conditions of dash. The cartoon suggests the area to have conditions. The conditions are showing conditions of dash. So here now, as you see, we are saying after the water went, it was the city's economy, reputation in tourism, and it is actually showing which shows drought. So now drought is being shown. So it actually identifies that the cartoon suggests the area to have condition of what? Of drought as indicated. It is captured there, it is drought. Drought is dash. Define drought. Drought is a long period without rain. It's a long period without rain. A prolonged period of absence of rainfall defines what we call drought. Absence of rain is what we call drought. A long period of no rainfall, which when it takes longer again, we start to see the manifestation of desertification, the failing of the ecosystem to sustain its biological life. Then we would see now what we call desertification taking place, gradual deterioration of the biological life within or of a given ecosystem, that is desertification. So the availability of food and people having access to it. If people have food and it is available and they have access to it, that's what we call food security. Food security is when food is there and they are having access to it as enough as they want. So insecurity is the opposite. When the food is unavailable, that is what we call food insecurity. The physical impact of the cartoon. The physical impact of the cartoon: swimming pool dries up, soil erosion. A physical impact of the cartoon, it actually shows uh, the physical impact of the cartoon. It actually shows you can see that we have got soil erosion taking place. Glass, we have got soil erosion that is taking place, to say that what happens if we don't have rain. Obviously, what would happen is vegetation deteriorates and then soils are washed off. We talk about soil erosion. Soil erosion is being shown as an impact of drought. And then causes of the problem in the cartoon. The causes of the problem in the cartoon, we can say that high pressure systems will result in what? In situations whereby we have got issues to do with absence of rainfall, and then at the end of the day, we experience drought. So it is high pressure systems, water restriction and water shortages force industries to reduce production. Restriction of water and its shortage force industries to reduce production. So if production is reduced, it is basically a challenge. Uh, it is a challenge for the economy. It is a challenge for the economy because production sustains the economy. We talk about our GDP, so it is a challenge to the economy. And then the construction of dash dams helps to increase the water holding capacity. The construction of DP and we are saying helps to increase water holding capacity. To increase water holding capacity, it has to say that we need to ensure that they are deep and narrow. They are deep and narrow. This reduces evaporation, and therefore we are saying holding capacity can be high because if it is shallow, it can evaporate. I mean, if it is shallow, it can just be on almost to the ground, and therefore no, we don't have more water in there. White also suffers extensive evaporation, so it is deep and narrow. A sustainable measure to address challenges. In order to address challenges, we need to, we need actually to, which is a measure to address challenges, is drought awareness. Drought awareness, we are saying it is a sustainable, it's a long-lasting strategy that can be used to address challenges. Because if people they know what is drought and how do we prevent it, as well as uh, solutions to it, that can be a sustainable measure. Adapt to change. It cannot be. Therefore, we need to understand that drought awareness is education, is campaign that can bring our people to knowledge. The sketch below regarding the significance of Earth's axis and the revolution around the sun. The Earth's axis and the revolution around the sun. So we are given spring equinoxes, and then we have got winter, December, winter solstice, autumn equinox, and then we have got also summer solstice, spring. This actually is basically showing the effect of seasons and how the Earth's rotation affects these whole issues or this whole concept of Earth article. How do seasons come in? So now we are given here now that the sun's rays, which we say if they are directly central, they are actually showing to say our equator is not actually is actually like diagonal, and then we have got the rotation axis, Antarctic circle, and so forth. So now this is one area which has been repeatedly been appearing. The Earth, the Earth rotates on an imaginary axis, how many degrees in the tilted Earth? When it rotates on, we are saying on the tilted Earth, on an imaginary axis, it rotates something like 23.5 degrees, which we can see that imaginary axis, we are saying it rotates at rotation 23, it is 23.4 degrees, 23.4 degrees, which we can calculate. If we can calculate it, we can calculate it again, which can also give us to say it is 23.4 degrees. And then the Earth rotates in anti-clockwise direction or from dash to dash. The Earth rotates in an anti-clockwise direction. In an anti-clockwise direction, that is from west to, we are saying it rotates from west to east. I'm sure you can see that is in an anti-clockwise, which can also from west to east. From west to east. Give the date of the summer solstice in the southern hemisphere. The date for the summer solstice in southern hemisphere. In southern hemisphere, we say that the date for the summer solstice, it is known that it is summer solstice in southern hemisphere. It is actually 22 December. In southern hemisphere, the summer solstice is 22 December. It is 22. I'm saying it is 22 December, which is also supposed to be known that the summer solstice, it is 22 December. And then explain how seasons occur. How seasons occur. Explain how seasons occur. How seasons occur. How do seasons occur? This, I want you to note that the earth revolves around the sun, and this takes around 365 and a quarter days. That is one thing. The earth actually, it revolves or it rotates, revolves around the sun. It revolves around the sun, uh, which takes about 365 about 365 and a quarter day. That is one point that we must know. And then also, I want you to note again that the Earth's orbit around the sun is not circular. Earth's orbit around the sun is not, it is not circular. It is not circular, however, but it is it's not circular, but it is elliptic. Elliptical, which of course means that during some periods in the year it is closer to the sun, meaning in some seasons during the year it is closer to the sun. It is closer to the sun some seasons. During the year, it is closer to the sun. That is one thing that you must understand. The Earth's orbit around the sun, it is not circular, but it is elliptical. And then in some seasons during the year, it is closer to the sun. And of course, meaning to say that at other times it is further away. And other times, other periods, it is further away. That variation and that causes seasons. That causes seasons. So I want you to know that the distance of the earth to the sun varies, therefore, with time. So when it is closer to the sun, and when it is closer to the sun and when it is far from the sun, that now defines seasons. So as northern hemisphere tilt towards the sun, as northern hemisphere tilts towards the sun, when it tilts towards the sun, it experiences the sun. It experiences the summer season. And the southern hemisphere tilts away from the sun, it experiences winter. Also, when southern hemisphere uh, when the southern hemisphere tilts, when it tilts away from the sun, tilts away from the sun, when it tilts away from the sun, it experiences winter. I hope this can make sense. So what we need to understand is that the earth actually it rotates around the sun about 365 and a quarter day. And the earth's orbit basically is not circular. And then it is elliptical, meaning that in some seasons during the year it is closer to the sun, in other periods it is further away. And that causes the seasons that we are talking about. Northern hemisphere, as it tilts towards the sun, it experiences summer. Also, or likewise, when southern hemisphere tilts away from the sun, it experiences a winter. Therefore, it is the position of the sun in relation to uh, the earth. So therefore, that's what causes what the season that we are talking about. That is question B 3.13b, 3.1.33b, and then differentiate between equinox and solstice, which is question 1.34. Differentiate between equinox and solstice. So equinox, actually, this is the period when the sun is directly overhead the equator. Equinox time period when the sun is directly overhead the equator. Overhead the equator. So therefore, that is and 21 March. 21 March. And of course, 22 September, the length of the day and night is equal throughout the what? Throughout the world. And 22 September, we need to note that the length of the day and night, length of day and night, the length of day and night is equal throughout the world. Is equal throughout the world. So now solstice we are looking at on 22 December or summer solstice, the sun is directly over the Tropic of Capricorn and southern hemisphere has got the longest day. It is the longest daylight and shortest night. It is 22 December, which we can also call the summer solstice. I want you to note that again, that the sun is directly over the Tropic of Capricorn. The sun is directly over the Tropic of Capricorn, which of course it is, and then southern hemisphere is long as daylight. Southern hemisphere is as long as it is long as daylight. So now it has the longest daylight. It actually has the longest daylight and shortest night. That is the solstice. It is summer solstice, which is known that the sun is directly over there. It is actually it is directly over the Tropic of Capricorn. Directly over the tropic. The word tropic has been omitted here. Over the Tropic The sun is directly over the Tropic of Capricorn. It is directly over the Tropic of Capricorn in southern hemisphere. It has got the longest day and night, the longest daylight and the shortest night. That is what you need to be known by shortest solstice. Also on 22 June on 22 June, the sun is directly over the Tropic of Cancer. 22 June, the sun is directly over the Tropic of Cancer, which also you need to note. Also, 22 June, the sun actually is directly over the Tropic of Cancer. It is directly over the Tropic of Cancer, and all places in the southern hemisphere will have the longest night and shortest day. And all places in the southern hemisphere all places in the southern hemisphere will have the longest night and shortest day. They have longest night and shortest day. That is one point to note with reference to the solstice, and of course taking into account again the equinoxes and solstice. I'm sure this is one subject which of course keeps on coming back and forth. We have been talking about it for some time now. Let's say question 1.35. Question 1.35. It says, explain the reason why the equator is warmer than the poles. This is one question which is also quite interesting, that the equator basically it receives direct sunlight. The sun, it actually therefore hits a small surface, and then the rays pass through the lesser atmosphere to reach the earth or to reach the surface, as that compared to the poles. So equator faces the sun all year round, as compared to the poles. Why the earth is warmer than the poles? Why the equator is warmer than poles? Why do we have the equator warmer than the poles? I'm sure this is one area or one subject that is quite interesting. Like I've said, that the equator receives direct sunlight. It receives direct sunlight. That is one point to take note of. The equator receives direct sunlight. Also towards the equator, therefore the sun heats up a small surface area. It heats up a smaller surface area. it eats up a smaller surface area, which of course we need also to know that the sun's rays pass through a lesser atmosphere. It passes through lesser atmosphere. I'm sure that you understand to reach the earth, to reach the surface. As compared to pores. So what you need to see here is that the distance of the sun's rays from the distance of the sun's rays to reach the equator is shorter compared than the distance that it takes to reach the poles. So what happens is you can see here is at the equator the distance that we are looking at, the distance is actually very limited. As compared, you can see that this is a shorter distance. If we can compare it to when it goes to the poles, you see that the distance is longer, and the heating effect is quite lesser compared to the equator. It's quite lesser if we look at that compared to the equator. So what we are saying is that the equator faces the sun all year round as compared to the poles. Again, affects this. The equator faces the sun all year round. It faces the sun all year round, which is not the same to equator to poles. So these are the points that you must take note of. Why equator is warmer or is having higher temperatures than the poles. It's because it actually receives direct sunlight. The sun travels a shorter distance to reach the surface compared to the poles, and also the sun is so directly aligned to reach the surface. The synoptic weather map that is given here, we are given a synoptic weather map which is given here to say the morning and dew point temperature. We are given some cold and occluded fronts. We are given warm front, and it is the season. The time was 23 February, and this is moderate tropical storm, which is El Nino. And then what else do we need to note? So in terms of which season that the synoptic map show, the season that it shows, it is it is based on the date. How do you know you are looking at the date? The season is compared or it is calculated. It is known by looking on the date of the map. The date on the map are also the position of the cold front that we must also look at, where the cold front is positioned. So now what happens is the season here, it is in summer because we are looking at February. Summer is the answer there. and then give 2 reasons for your answer. I have already mentioned some reasons that we are saying 23 February 2024, date, date given. We are saying the date on the map, it actually says 23/02/2024. So as we know that February is what? Is summer. And also we can look at the position of the cold front, which you can see that the cold front is actually looking, or it is quite far south than what it is. The position of the cold front. Cold front. The cold front is more south. When it is too much south, it actually shows that we are more south position. That identifies that it is what? It is summer. And then we can also maybe want to talk about, we are talking about the high pressure, which also is also, can also be identified that they are too much at some southern, they are too much south anyway. And then identify features, identify weather features A and B. Weather feature A, okay, A, as you can see, A, it is showing weather feature A, it is looking at this, which is a cold front. And if you look at B, it is actually looking at this. B is showing this feature that is also a warm front. So our answer is A is a cold front. A, that is a cold front. And then B is a warm front. A is a cold front and B is a warm front. And then I'm sure I remember we said that triangles resting on the line, that is a cold front. That is cold. And then if we have got also another one where there are semicircles that are resting, we say that is a what? A warm front, which you can actually see if you can look at this. When you look at our diagram, you see these are triangles that are resting there, which actually shows the cold front that we are looking at. And then of course you see this, which also shows the warm front that we are looking at in terms of A and B. And then the question next is saying, name the pressure belts that are found in the following latitudinal position. The latitudinal position around 0 degrees, we are saying the pressure belts that are at 0 degrees. At 0 degrees, if you look at 0 degrees, we talk about 0 degrees, obviously that is, we look at the equatorial low pressure belt, that is the equator. to the low pressure, and then 30 degrees. I'm sure if you remember with this, we talk about the subtropical high pressure at 30 degrees. At 30 degrees, we talk about the subtropical high pressure. It's 30 degrees. At 30 degrees, what we find there is that we have the subtropical high pressure. Subtropical high pressure, we have it at 30 degrees. Describe the weather station for Taung in Northwest Province. The weather station, which we can look at this. This is the weather station. We have got clear skies. You see this circle represents weather station. Which is actually, we are looking at this circle here, which has got a easterly wind direction, which is blowing at 10 knots. So what is happening here is when the circle is clear, that is actually showing that we have got clear skies. We have got clear skies, which means no rainfall or no clouds. And then we need also to say is that there is 0% cloud cover. In other words, we also talk about, we also have light winds. Light winds which are blowing at 10 knots. This is the 10 knots that we are talking about. I'm sure you know that one full line represents 10. If it is half, it is 5. Light winds at 10 knots. And then we also need to know that we've got an easterly wind direction. Easterly wind direction. This is it. We've got the easterly wind direction. So we just took this whole thing is what we are interpreting, which we can also need to understand that we have got some 10 degrees difference between the temperature and the dew point temperature, which is 17 minus 7 minus 7 is 0, and 22 minus 1 is 10. So between the dew point temperature and we are saying the air temperature and dew point temperature has got a 10 degrees Celsius difference. Air temperature and dew point temperature. It is 10 degrees difference between the air temperature and the dew point temperature, which is 27 minus 17 is the difference that we are looking at or we are referring to. This 27 minus 17 gives us the 10 degrees difference between the air temperature and the dew point temperature. That's the question that we have answered there. It is a case study below a phone winds. We have answered also, if you remember and look at Metric Hub, you will see also this. It's a word in German, also means hair dryer, and that is just what it's like. A hot, dry wind that sweeps down a mountainside, packing everything in its path. So it is powerful enough to raise air temperature by many degrees. This is the strange and sometimes dangerous weather event known as the phone will take place. The, the phone, the term phone comes from the Alpine region of Europe, but the same effect has been given different names elsewhere in the world. In some parts of US, such as the Rocky Mountains and the Alaska, they are known as Chinook winds, while in South Africa it's known as Beige winds. For your own information, Beige winds, we are going to do them until grade 12. You need to master and note them right now so that you don't make mistakes as we go. So now, I am sure that go check again on Metric Hub on issues to do with what we call phone winds or beige winds. They are well defined. So define the term phone wind. Phone winds, we say warm, dry wind that descends on the leeward side of a mountain. It's warm, dry wind that descends on the leeward side of a mountain. Descends as to say it falls. That descends on the leeward side of a mountain. We call that phone wind. So now, what we can see is that we see this air rising. The windward side is the direction from which the wind originates. The windward side, that is direction of origin of the wind. And then it rises because of also the plateau there. The air is also going to just form cumulonimbus clouds that are going to be formed that result in heavy rains that are found basically on the windward side. So as the descending air is actually found, the descending air actually is found on the leeward side. This is actually, remember that when the wind descends, when it falls down, it warms up. What causes this thing, I'm saying, is the air falls, as the air descend, it warms up. That's one thing that happens. Falling winds, it actually hits up with what? With height. I'm sure you shall go and note as we go talk about the adiabatic cooling and adiabatic heating, whereby we are saying the air is heating up with distance and also cooling with distance, which is at every 1000 meters the air warms, or the air, it actually cools by a degree Celsius. So by a degree, so that's one other subject that we are going to talk about just soon in geography. So give the name of the site that of the mountain where warm air wind rises. The warm air wind rises on the windward side. It is known as this is known as the windward. It is known as the windward side. That is the windward side classing, where the wind is coming from, which I'm actually showing you here, that the wind is coming from the ocean here, and then it rises. We call that the windward side, the direction from which the wind is rising, and then explain the process taking place in the leeward side of the mountain. On the leeward side, 1.53, 1.5.3, in the leeward side, weather conditions or what occurs there. I want you to note that taking place on the leeward side. So now what we need to understand is that it actually, the air that is risen from the windward side, we have got the air actually, it descends down on the leeward. What takes place at the leeward side of the mountain, we have got air basically, it descends or it falls down after condensation has occurred. After condensation is occurred, therefore, the falling winds is actually dry. So what happens is that the air actually, it warms up as the air descends. As the air descends, it actually warms up. It warms up by dry adiabatic lapse rate. It basically warms up by dry adiabatic lapse rate. The dry adiabatic lapse rate classing, adiabatic lapse rate. This is just the warming up of air with what, with increase. I mean, with a decrease in height, the air, it warms up with a decrease in height as it falls. So what happens? There is now very little moisture in the atmosphere, and then the temperature rises rapidly on the leeward side of the mountain. There is very little moisture in the air, in the atmosphere. So now a temperature rises on the leeward side of the mountain. So that is basically what needs to be taken note of. It is certain systems that are occurring, basic stuff that occurs when the air descends. It actually warms up because it's actually at a dry adiabatic lapse rate, which is caused because of very little moisture in the atmosphere. So the temperature basically increases on the leeward side of the mountain because of the dry adiabatic lapse rate. I guess I have talked about this also severally. So now, uh, I want us to look on question 1.54. 8 lines explain possible challenges that a phone wind can cause to the environment. It has been mentioned severally again. I have answered this question. It actually can cause uh, runoff fires, which is called veiled fires. Veiled fires that can burn forests can result because of this. We have got also natural disasters that can also cause, natural disasters may also form there. We also have plant and vegetation deterioration of plants and animals. The population, the plants, they also dry, animals, they die, starvation of animals. We can also talk about serious drought. Serious droughts are experienced in such places where we have got this. We also have got also possible flooding of coastal places. Coastal places, they do flood due to ice melting. When ice melts, coastal places can flood because of the melting of ice as a result of high temperatures that are experienced there. So these are some of the problems which can also even have uh, environmental problems. We can also talk about the just the upset of ecosystem. So some of the things that we can give as problems that are resulting from these systems that we are looking at. And then we are given features of intrusive volcanism, which we can say intrusive landforms. Intrusive landforms, we need to look at that. Intrusive landforms, match each of the description with the letters on the sketch. Intrusive landforms that we are given here. First question, it is the largest of all intrusive landforms covering thousands of square meters. We say that the largest of all, which covers thousands of kilometers, which can actually need to be known. We've been talking about these landforms. Also, you can remember to say we talked about the batholith, which we say that the answer is largest covering thousands of kilometers. It is C, a rupture. in the crust of the earth that allows hot lava, volcanic ash, and gases to escape, which you can see that it must be known that that is the volcanic fissure, which we can of course say that it is what it is F. The exposed laccolith then forms a U or a mountain, which we say that that can also need to be known that a U or a mountain, which we can say that that is G. Go check also, it has been already answered on our channel, a horizontal intrusion of igneous rock that forms a sheath, uh, which forms a sheath, which you can see that we are seeing that it's a horizontal intrusion that forms a sheath. You can see that is E. E, as you can see there, it is an igneous intrusion that forms when sedimentary strata surge, creating a basin-shaped mass. A basin-shaped mass, which you can also see that it is an igneous intrusion that forms when sedimentary strata surge, creating a basin-shaped mass, which is, as you can see, that can also be defined by A. Vertical intrusion of igneous rock that forms a wall. Vertical intrusion of igneous rock that forms a wall. That forms a wall. That you can also vertical intrusion that forms a wall. You can see that is B. It is an igneous intrusion that forms when strata are forced upwards. That's forming a mushroom shaped. That also you can see that forms a mushroom shaped. That also can be seen, that is D. That is D. And then we go to the next question. I talked about slope elements. Slope elements are also covered on metric hub. Please refer on metric hub. It actually has a very good lecture on this. So we say a low anchored concave slope. A low anchored concave slope number 2.2, low anchored concave slope. That is of course D. We talk about the pedicline plane, and then it is soil creep occurs here. The soil creep, which is of course the movement of soil which is formed on the slope face, which is A. The slope is mostly suitable for farming. The slope is mostly suitable for farming. It is obviously at the pedicline plane, which we can say D again. The most vertical inclined slope is the free face, which is B. Vertical inclined slope, it is B. is a constant angle. A constant angle is also maintained when you look on C. Constant angle, and then the slope is also called the debris slope. Also called the debris slope. To say debris is with that material, which is also found on, say, that material falling from A, B, it accumulates at C, which also forms the debris slope. Eroded material cannot accumulate on this slope. It cannot accumulate on the free face that we mentioned that it is B. Material cannot accumulate on the free face. And then we have this slope is convex in shape. It is convex in shape, which of course we can see it is a cliff. Which we find that it's what is A, is convex in shape. It is A. Which I want you to see, just for you to note. Just for you to see. Take note of this. We are saying the slope elements are quite common and you need to be able to exploit them. You must be able to explain them. As you can see, that's what you need to know. Slope elements. We go to the next question. The next question, it is actually giving us to look at the cloister domes and cloister basins. The deep slope formed because of various resistant rock strata. Define the term cloister. Define cloister. Basically, this is known as a ridge. Is basically a ridge that develops in a tilted sedimentary rock. A ridge that develops. A ridge that develops in a tilted sedimentary sedimentary characteristic rock. In a tilted sedimentary rock characteristic. The rock is characterized by gentle slope and steep slope. Characterized by gentle and steep slope. It is characterized by gentle and steep slopes. And then describe the difference in the formation of cleisters in the diagram A and B, the cleister dome and the cleister basin. The formation, the differences. A, basically, if you see the cleister, this one thing that you should understand is that it forms when the rock strata is in the center and are pushed upwards. It forms when the rock strata is at the center and is pushed and is pushed upwards. And then we also, in terms of B actually forms when the rock strata is at the center and pushed downwards. The deep, as you can see, the cleister basin. It's at the center. Obviously, as you can see, a basin is supposed to be formed when we have a dip. So we have what is formed when the rock strata is at the center and then it is pushed downwards. That results in the formation of the cleister basin. Obviously, a dome is now to say it's a rock outcrop that is formed when the rock strata is pushed upwards. So the difference basically appears in the fact that it is pushed upwards and it is pushed downwards. That is where the variation comes from. And then now, other than cleisters, name one other type of ridge that can be found there. We have got the Hodgeback. I think you remember on this one we talked about the Hodgeback. And then we also talk about the home clonical ridge. Remember to say this, I have already given answers to it and I have already explained this one also in various videos that we have done. 2.3.4. Describe the difference between the deep slope and the scarp slope of the crest. So the deep slope and the scarp slope. Deep slope and the scarp slope. What we basically need to know here, class, is that the deep slope is basically gentle. The deep slope is gentle and the scarp slope is steep. The scarp slope is steep. The deep slope is what? The deep slope is gentle. And then explain how human can utilize Q-stars. 2.35. Uses of Q-stars for humans. We can talk about many things here. One, Q-stars. We can see that farming takes place in the Q-star valleys situated between ridges as the flat surface is covered with fertile soils. We've got agricultural. We have got agricultural farming on rich, fertile flatlands. There's farming, agricultural farming. We can also talk about where we have got cluster basins form artesian wells, which are sources of groundwater. They can harvest groundwater. They can harvest clean groundwater. For domestic uses. Groundwater can be harvested for domestic uses in terms of the clusters and also oil mining. People can also mine oil in clusters. That can also be one other function that must be taken note of. Clusters can also be used for mining of oil because they can trap oil. We are given here the diagram showing a valley. This is a valley that is given here, surfacing the valley walls and erosion, which is actually cutting deep. So now, we can talk about canyons, landscape develop in a dash rock. The canyon landscape, they are found, the canyon landscapes develop in horizontal rocks. They develop in horizontal rock strata. This is also on metric hub class. It's on horizontal rock strata. And then the question is saying draw a free hand sketch of contour lines representing a canyon above a land, a free hand that can represent the canyon above 2.41, 2.4.2. If you can see this question saying draw a freehand sketch of the contour lines representing the canyon above. So we shall see that we have got very steep, and then we have got gentle, and then we have got steep. So what happens is we shall see that the contour lines which are showing the valley steps, it can be seen that this can be otherwise showing something like this, which we can say that it is 60 and 60. And then we also have the gradient becoming also, which can also show a decrease, that can also illustrate a decrease, which we can give to say this can also identify to say 40, 40, and then it is now becoming less steep as we go down. It's becoming less steep, which can also decreasing with a 20 variation that can also show us to say we have got a 20, 20, which would cause will be the same that we are going on the other side of the valley, which is also going to start seeing less steep. We are now going to the other side, which is 40, 40, and then we have got a distance which is also giving us 60, 60. So what we are drawing class here, we are just illustrating this landscape. We are basically showing this landscape which we are looking at here. We are just looking at the landscape of a cross section of a gorge. So we are basically looking at something like that to say this canyon is what we are looking at, to say that we have got this variation which is showing that they are very steep on the sides there, and then it becomes a little bit spaced here, there, and then it takes again the same shape going there. So now what I want you to look at is that spacing, and then that is how the contour lines will basically represent. Explain the main process responsible for the development of canyon landscape that develop in areas where horizontal strata have an equal resistance to erosion. 2.43 they develop in a landscape with the horizontal strata with an equal resistance to erosion. So now we have got the effect of tectonic movements. There is tectonic uplift forms large flat plateaus. There are large flat plateaus that forms there. And then we have got rejuvenated rivers that are cutting deep. Rejuvenation The valley floors actually create deep valleys. These deep valleys we are talking about there, which we say these are the same as the canyons. The effect of unequal resistance to erosion, which is also accompanied by tectonic upliftment, which at the same time river rejuvenation, the regaining of the river energy that we call river rejuvenation occurs, and therefore obviously it has got its impact in the valley deepening. Therefore we have got this deep valleys. This erosion is caused by rejuvenation that we are talking about. The rivers becoming more erosive, the rivers becoming more energetic, the rivers regaining their strength, their velocity, and many other factors have come in. So, what impact does canyon landscapes have on people? The impact of canyons on people. One, we've got tourist attraction. Tourist attraction, because of them, they are good source of tourist attraction. We also need to look at uh, is actually there is also the steep ragged landscape. Does affect settlement and farming. Farming activities are affected in these areas. We can talk about the construction is disturbed also, and then explain how Karoo landscape form millions of years after a canyon landscape. 2.54, 2.4.5, 2.4.5. How Karoo landscapes, Karoo landscapes form millions of years after canyon landscape. I guess you still remember the issues to do with scarp retreat and the issue of scarp retreat being the main process. So scarp retreat is the main process here. We have scarp retreat, which of course causes loss of ground over the what? Over the whole slope. It takes place on the scarp slope. Scarp retreat occurs on the scarp slope, and then this causes loss of ground over the whole slope, but but no loss of weight. Resulting in loss. Scarp retreat, basically it results it results in loss of ground over the what? Over the whole slope. It results in loss of ground over the whole slope, but of course, not, but no loss of height. Height is not lost. So what happens is that as the plateau surface narrows, canyon floors becomes wide. As the plateau surface as the plateau surface narrows, the canyon floors becomes wide. Becomes wider and a pediplane forms. So finally now, if the pediplane has formed now because of scarp retreat, we finally have the Karoo landscape forms developed from the canyon landscape. Hence we have Karoo landscape. It developed from canyon landscape. So this examiner here class is just trying to test you to be able to explain and understand the application and the relationship between these two systems with reference to scarp retreat, which of course results in loss of the ground over the whole slope, which at the same time the height is maintained. So as the height is maintained, it also have the effect of the narrowing of the plateau, which the canyon floors they become wider, and then we have got a formation of a pediplane. A pediplane is just a flat ground. As you see, flat ground which is being formed is now leading to the formation of the Karoo, the Karoo landscape that we are talking about. And then we are given also the structural landforms that are given here. The structural landforms that we are given here identify the rock structures at X and Y. The rock structure at X, which means from here, X is this one. The rock structure that we can find there, we have got horizontal structure, which is causing the pediplane, the plateaus and all these conical hills. So we have got a segment, a horizontal structure. We have horizontal structure. And then on Y, we have got, of course, inclined. As you can see, this is always linked to inclined rock structure. Inclined rock structure. The horizontal in Y. Is the landform horizontal or inclined? Is landform D horizontal or inclined? Landform D As you can see that this is landform D is also inclined landform. It is inclined. And then differentiate between landform A and B. Landform A and B. Differentiate between landform A and B. We are looking at A. It has got a broader base than B. B is smaller than A. Landform it has a broader base. It has a broad base than B. And then if you see B is smaller than A, it is smaller than the difference. That is question 2 point. That is question 2.53. And then question last, it says, paragraph of 8 lines explain significance of the structural landforms for humans. This is also check on metric hub class. Term 2 work, landforms. This is also well answered. Significance of the structural landforms to humans. So if you can look at this, the significance of the structural landforms, 2.54. We need to understand that in humid climate, the slopes of hills are suitable for farming. In humid regions, we have got in humid climate slopes. We are saying farming in humid climates on slopes. On the slopes, we can have farming taking place. And then we also need to look at basaltic plateaus are great tourist attraction. The basaltic plateaus have great tourist attraction, and therefore we have got revenue that we can look at. And then we may also look at human settlement and agriculture. We can look, for example, those ones which we can look at the Deccan plateaus in India. We also have canyons, landscapes have impressive scenery, and tourist attractions also. They can be used for recreational purposes. They are important for recreational purposes. We have got recreational purposes that can also be there, e.g. hiking. We also talk about Karoo landscape are suitable for stock farming. They are good for stock farming. For farming will also be a good uh, activity that can also be done in Karoo landscape. This is actually some techniques that we can have to look at. This is just some map work, which you can also look at. Where is Northwest situated? Queenstown, where is it located? Queenstown, in which province or region do we have Queenstown? For us, we need to know that it is in Eastern Cape. This you look on the number and then you identify the map index, which will give you the latitudes and the longitudes. I said latitudes, they are horizontal, longitudes, they are vertical. This is long, this is lat. So horizontal lines running on the map are called latitudes, and then the longitudes are also the vertical ones, which also runs the feature found on the grid. You just check on the map again and identify the grid and explain and see. We have got these are also shown by the shape of the contour lines. Contour lines are used in this identify landforms through contour lines. How the contour lines shape themselves gives you to say we have got contour lines that are going to be forming and forming something like that, which would also see that we can have possibly a river valley that is forming a saddle, a spur, and all those. Um, we have got situations also where you are given to say seasons which have got highest rainfall. It is just name the season in which Queenstown received the highest rainfall. So you can see that if you can look at this, where we have highest rainfall, you can actually say the season in which Queenstown received the highest rainfall. You are looking on the average precipitation, which is given from January to December. So which season do we have the highest? We can look on these figures and then we can basically just work it. Is the hiking recommended for novice, first or expert hikers? It is actually based on that. It is based on the shape of the contour lines. So I want us just to look at the last part, which is the GIS. GIS define attribute data. Attribute data, it is a descriptive information of any object or feature. It is actually descriptive information of any object or feature. We call that is called attribute descriptive. This is when we are defining something, we are saying the descriptive information of any object or feature is what we call is called attribute data. Wide river, It is called steep-sided valley. Authors explain one attribute that influence the location of silo in block. This, we just look at that, which we are saying the silo is used for keeping harvest. So it has to be things to do with agriculture in this case. It has to do with agric in terms of agric advantages. If you can look at the silo is can be built where farming is taking place, so it can be near cultivated land, proximity to cultivated land, nearness to cultivated land. We have to build that silo near the farming area to reduce transportation. It is also the accessibility, transport accessibility. Transport accessibility can also influence to say there is access to the place. We can also talk about the availability of flat land for building as well as for agriculture. Orthophoto map has a high resolution. Does this mean that the orthophoto map is low level of clarity? So if the resolution is high, it means it has got high clarity. Resolution is the ability of us to see the landform features that are there. So if resolution is high resolution is equals to clearer image. Images are clear if resolution is high. Explain why the orthophoto map has high level of clarity. Why orthophoto map has got more level of clarity, 3.34. 3.34. High clarity of orthophoto map, it is because more pixels have been used. More pixels have been used. It can make that clear vision. The feature on the orthophoto map are clear. That is why we can say though the readability or the clarity of that picture, the cultivated land in block E5 and E4 is an example of coordinate based. Explain this statement. Coordinate based, it means that this can actually identify that it's an example of a polygon or a vector data. It's an example of vector or raster data. If you can check also on previous videos, we have confusion that explains the difference between raster and vector data. Pixels are the ones that enables the clarity or the resolution of an image. More pixels, the more the pixels, the better the clarity of an object. So, class, thank you very much for the class, and thank you very much for the lesson. All the best, and please don't forget to follow the channel by subscribing to membership, so that you become part of this group, and also ensure that you subscribe anyway to keep connected. Have a great and beautiful time. Thank you.